This is 5G wala. इसमें कनेक्शन थोड़ा कम आ रहा है. Thank you.
Ma'am, done.
Done. Okay, fine. Let's move on to the next question, the 12th one. So in this question, you're supposed to verify that x cubed plus y cubed plus z cubed minus 3xyz, which we had written over here. This is our x cubed plus y cubed plus z cubed minus 3xyz. Prove that this is equal to half of x plus y plus z multiplied by x minus y whole square plus y minus z whole square plus, just a minute, plus z minus x whole squared. So you see the formula that we have already, what is that? Let's write it over here. We know that x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z multiplied by x square plus y square plus z square minus xy minus yz minus zx. This is something we already know. We've written it in the previous class as well. See, it's written over here. Wait a minute. I think this is working a little slow. Just a minute. I think I'm having network issues. All right. So from here, now who will tell me from here, how can we get to here? See, everything in the left hand side.
You have to multiply with the right hand side.
No. See, you have the right hand side. You are given this. This is something we already know. We know that this is something we already know. From here, we are supposed to get to this, the verify part. See, the LHS are equal, right? The left hand sides are equal. All we have to do is you have to change something in the right hand side. Preshita?
Yes, ma'am.
Can you tell us how to do this? Think about it. So see, even in the RHS, the x plus y plus z part is the same.
Ma'am, actually,
X
I
plus y
just
plus z.
joined.
It's okay. You were there in the previous class, na?
Yeah.
In
So,
the previous
what
class,
do
we did this identity. So now this question says you have to verify that this x plus y plus z, this entire thing. Okay, you have to verify that. Now we are starting with the solution. Okay. Now we know that this thing, we know that this identity is there from the previous class.
Okay.
Now we notice one thing. We say, well, the left hand side are just the same.
Yeah.
And even in the right hand side, one bracket is the same. Where is the difference? The difference is there in the second bracket. We know that this is x square plus y square plus z square minus so and so. We have to change this somehow into this half. This is additional. And this thing, x minus y whole square, y minus z. So from here we are supposed to get this thing.
Okay.
Okay. So let's try to solve this. See, you can, okay, before I give you guys a hint, try it yourself. Tell me, just think about it. How can we go from one thing to the other thing? Hmm? Think. Yes? Just think about it. There's a x minus y whole square thing over there. Yes, Prishta, you were trying to say something.
Ma'am,
No,
will
ma'am,
mul-
I can't get any clue.
Acha,
ma'am
acha,
will
okay.
multiply everything. Like the x plus y plus z into will multiply x square.
If you multiply it, you're not really going to get anywhere. If you multiply this, let me show you what I'm talking about. See, if you multiply this thing, you are just going to get the LHS. What we can do is, see, the only difference is in the green portion. Okay. So what we can do is, we can say, okay, see, what is x minus y whole square? Yeah. We know this identity. We know it very well. Yeah. What is x minus y whole square? Preshita,
X square plus y square.
yeah,
Minus 2xy.
minus 2xy, right? So do you see something common? See, over here you have x minus y whole square. Here, in place of x minus y whole square, you have x square plus y square, which we are supposed to have, and minus xy, not 2xy. You have minus xy. So that means some few changes we need to make. So what we are going to do is, we are going to say, well, x minus y whole square is this. And here you have y minus z whole square. So y minus z whole square is what? Y square plus z square minus 2yz. So Avni, what is z minus x whole square?
Z minus x whole square. Yeah, it will be x z square plus minus x square.
Minus
Plus, yeah, plus.
plus x square,
Then minus 2x 2zx.
okay, minus 2zx. Fine. So now, if you add all three of them together, why are we adding them? Because as you see in this thing, the green bracket over here in the top statement, they have added the x minus y whole square plus y minus z whole square plus z minus x whole. They have added the three of them. So let's add the three of them. So when you add these, what you're going to get? When you add the LHS, you're supposed to add the RHS also. So that is going to be x plus y, sorry, x minus y whole square. We are adding it with what? Y minus z whole square. Then plus z minus x whole square. This thing we are adding with what? We are adding everything that is on the RHS. So just see here. We are adding all of these. Oops, sorry. So here you have x square plus x square. X square in the first one, x square in the second one. That is going to give you 2x square. Yes.
Yes.
Y square plus y square. That is going to give you 2y square.
Yes.
Z square plus z square is going to give you 2z square. Now, minus 2xy minus 2yz minus 2zx. So let's just write it as it is. minus 2xy minus 2yz minus, this is z by the way, minus 2zx. Okay. Now, from here, can we take 2 as common? Because see, in every single term, you have 2. 2, 2, 2, 2, 2, 2. So can we take can we take 2 as common? Yeah.
Yes.
So now it becomes x square plus y square plus z square minus xy minus yz minus zx. We have taken the 2 as common. So you see that this thing which we had in our identity, this x square plus y square plus z square minus xy minus yz minus zx. This is the same thing as this one. Right? It's the same thing. So we can say, we can just take the 2 to the other side. So now write it like this. That implies x cube plus y cube plus z cube, or never mind, don't write it like this. So we start from here, okay, this point. That implies, now this entire thing on the LHS is equal to this entire thing on the RHS. So if you divide the LHS and the RHS by 2, so that becomes half of x minus y whole square plus y minus z whole square plus z minus x whole square. Okay, you have divided the entire thing by 2. This is equal to the RHS divided by 2. So when you divide 2 by 2, it's just nothing but 1, right? So we're left with x square plus y square plus z square minus xy minus yz minus zx. So it turns out that this particular expression in the bracket over here, which we have written in our identity, this one, this can be replaced by half of this thing. Which is exactly what we needed over here. So let's write it like this now. That implies half of x plus, sorry, that implies x plus y plus z multiplied by x square plus y square plus z square minus xy minus yz minus zx. This can be written as x plus y plus z multiplied by what? We are replacing it. We are replacing this thing. We are replacing it with this one, the one in the purple color. So what does it become? Can someone tell me? Yeah, yes, Avni. Yeah, Manish.
Ma'am,
X cube plus Y cube.
See, that thing is there in the LHS. Okay, we are talking about in this expression over here. Okay, you have the pink highlighted thing that we are replacing with the purple highlighted thing. So just replace the pink thing with the purple thing and tell me what does it become? What should I write here?
So you're saying the first equation from the second one, which you highlighted.
Okay, only look at this portion now. See, do you see that these two pink things that I've highlighted are the same thing?
Yeah.
Yeah, they're the same, right? So they are same because of this equal to sign over here. So we are replacing the pink thing in the left hand side now with, we have just multiplied x plus y plus z over here now. So we have to just replace the pink thing with the purple thing. Now tell me what will it become? Yes, Arvind.
Ma'am, they both are the same color.
I'm talking about this one. You're supposed to replace that with this thing.
Oh, okay.
Yeah. Tell me. Half.
So it will be half a bracket x,
Yeah.
bracket x minus y whole square
Yeah.
plus bracket y minus z whole square
Then
plus z minus x whole square, then bracket close.
bracket closed. Okay. So, acha. Now look at only this portion. In this portion, the half we have written over here. Can I write it in the front because it's the constant term? So can I write it in the front? I'm just not
Yes.
doing anything. I'm just bringing it over here. Okay. So I've just written it at the front, and this becomes x plus y plus z. Then the rest of it.
Yes.
X minus y whole square plus y minus z whole square plus z minus x whole square. Okay. Now you see this thing, x plus y plus z. Let me just give these things name. Okay. This is, let's say, your 1, not 1. Let's come to just a minute. So this is your equation 1. Your equation 1. Okay. And this is your equation 2. Can you see that this 2 is basically the RHS of the equation number 1? Yeah. The 2, the second one, is actually the RHS of equation number 1. Can you see that?
Yes, ma'am.
Yeah. So the LHS is basically the yellow part. So since the 1 is equal to this, the second thing is equal to the third thing. So we can say, therefore, from 1, we have x cube plus y cube plus z cube minus 3xyz. It was supposed to be equal to, x plus y plus z into this entire thing. But since that itself is equal to the thing which we've written in number 3, that means this we can just write the third one over here. Let me know if there's any doubt in this. Kindly note it down and let me know if there's any doubt in this. Have you all written it down?
Yes, ma'am.
This question was a little theoretical, na? It was a little boring.
Yeah.
Did you guys find this
A bit
question boring?
like
Yeah, because it is.
it's a bit hard to understand.
Yeah, okay. Which part is hard to understand? Let's clear it out. The entire thing. Yeah.
Ma'am, like the not much, but when is the first
It
time to
has too many
understand?
terms.
Yeah.
Okay. Let's look at something simpler, okay? Don't write this down. Just this is for your own understanding. Let's say I tell you
Okay.
that A, and this is something we studied in Euclid's geometry, if you remember, that A is equal to B. Fine. A is equal to B. Now, they are asking you to prove that A is equal to C. They are asking you to prove that A is equal to C. That means you need to show from here, if you can, if it's possible, then you need to show that B is equal to C, right?
Yeah.
If you can show that B is equal to C, that means the LHS will also become equal.
Yeah.
That means this you can easily prove that. So once again, let's go through this once again. You know that A is equal to B. They are
Yeah.
asking you to show that A is equal to C. So
Hmm.
what we have done in this, we have shown that B is equal to C. And since
Took
A is
it.
also equal to
Yeah.
A is also equal to B, that means since A is equal to B and B is equal to C, we have shown. This is something that we have
So
shown.
therefore, A
This
is
is
equals
something
to
that
C.
is known. So that means A is equal to C, which we had to prove. Okay. Now, what happened here is, Acha, is there any student who understood this very clearly?
Ma'am, which part?
The entire question. No one? Acha, Avni, how much do you think you understood? Like 50%, 30%, 70%?
Ma'am, I understood till equation 2.
Okay, then Acha, let's do one thing.
Before
Okay. So you understood from the starting till equation number 2 or maybe halfway there. So let's do one
yeah.
thing. Avni, you try to explain it to the rest of your classmates, okay? So you tell and I will dictate it. I will write it on the screen. And then let's see. So what we know given. So first of all, we know that. Yes, Avni, what do we know by our identity, which we did in the previous class?
We know that x plus x the whole square is equal to x square plus y square equal, wait,
From the previous class, which identity did we do? X cube plus y cube plus z
x
cube.
cube plus y cube 3xy.
Okay, is equal to how much? Yeah, Avni?
1 minute.
Half x plus y plus z.
No, I am not asking you what are they asking us to prove. I'm asking what do we already know? The identity
X
which
plus
we
y
studied.
plus z into x square plus y square plus z square minus xy minus yz and minus zx.
Till here, everyone is clear till this point. Everyone. If there's anyone who has any doubt here, ask me now itself. All clear? Okay, thank you, Preshita. Anyone else? Avni?
No, ma'am, it's clear now.
Clear, good. So, Abdul Jabbar, Munir, Zain,
Ma'am, it's clear.
till this point, everyone is clear. Okay, Riaz, Abdul Rahman,
Yes, ma'am.
Chalo. Good. So, till here it's clear. Avni, what's the next step? First, let's write what do we have to show. To show that this
X
thing,
square plus y square plus z square minus 3xyz is equals to half x half x plus y plus z.
okay, just a minute. We have to show that
Yeah.
This entire thing, let me just copy paste it. We have to show that. So this entire thing with just this will be different, and this will be over here. We have to show that this is equal to x minus y whole square plus y minus z whole square plus z minus x whole square. This is what we have to show.
Yes.
Okay. Now remember what we discussed, that if you have to show that A is equal to C, and you already know that A is equal to B, then what can you show? You can just show B and C to be equal, right? So this entire yellow thing, I'm not going to name all those terms one by one. So this entire yellow thing is equal to this thing. So even in the right hand side, we have seen that this portion, x plus y plus z, is equal to this portion. So over here, there is no change. So x plus y plus z is not
Ma'am,
the
but
reason.
can't we prove this with the Euclid's geometries, like the whole thing, rather than doing it step by step, like
Okay, how can we prove it using Euclid's geometry?
that if A is equals to B and A is
Yeah.
also equals to C, so then B and C will be equal. Things that are
That-
equal to one another are equal to
That is exactly
different
what we have done, na? See, over here we said from one we have. What we did was we are actually applying Euclid's geometry over here. Let's come to that. Just step by step we're going, okay? See, over there, what you
Okay.
have to do, Preshita, is that A is equal to B is something that is given. Okay. Meaning, this is the first one, A is equal to B. Then you have to show that A is equal to C. For this, you have to show that B is equal to C, right?
Yeah.
So this entire thing that we were doing was we were showing that B is equal to C. Got it? Yeah, Prishta, okay, fine. So next what will be our step? See, what I was saying is that in these two RHSs, between what you have to show and what you already know, see that the pink portion is the same. So that means the pink portion is not causing any change in our RHS. So this is something we can just ignore for now. We have to show that this, now we have to show that the rest of it is equal to this. So Avni, what do we do now? What can we do from here onwards?
Uh,
Yes.
Ma'am, the x plus y plus z, and we have to multiply the whole thing, like the right hand side. We have to multiply x plus no.
See, when you multiply it, what we did was in the previous class, when we multiplied it, see RHS, it's written over here. When we multiplied the RHS, this is what we got, the entire long thing. And from that, we got the LHS. So what is going to happen if you multiply the RHS? You are going to get the LHS, the yellow portion.
Okay.
Huh? So multiplication of both of these brackets is not going to solve our issue. We have to think about what we are going to do is we are going to show that this green portion is equal to this green portion. Is this okay till here, Preshita?
Yes, ma'am.
Avni, clear till here?
Yes, ma'am. Clear.
So we are going to show that this thing is equal to this thing. Because there's a half also over there, so we cannot ignore it. So we're going to show that this thing is equal to this thing. Till here, is it clear, everyone? Please respond. We won't move ahead until every single student is clear with this. Looks like there are some doubts. What happened? Yeah? Avni?
Yes, ma'am. 1 minute. I'm just going to the answer.
Yeah. Yeah. Shall we move forward, Avni?
Yes, ma'am.
Huh. So we have to show that this thing is equal to this thing. Now, who will tell me how to do this? Yeah? Prishita, do you want to give it a try? See, Prishita, till here it's clear, na? Till this step, till the last step.
Yeah.
So we have to show that this thing is equal to this thing. How do we do that?
Ma'am, maybe we can open the brackets inside.
Okay. So we can open the bracket. So this is equal to, we are going to show this thing. Okay. So in the RHS, what do we have? We have this. Now let's open the bracket one by one. So this is equal to half of, open the bracket, x minus y whole square is how much? X minus y whole square is how much?
X square minus y square. No, x square plus y square
Plus y square
minus 2xy.
minus 2xy. Okay. So I think I should write it a little bit smaller because it's not going to be able to fit everything over here. So x square plus y square minus 2xy. Okay, then next term. Yeah,
Y square minus plus z square minus 2yz.
very good. Y square plus z square minus 2yz. Next term. Yeah, next term.
Z square plus x square minus 2zx.
Very good. So this is equal to this.
Ma'am, now I understood it.
Good. So from here, what is happening is half
So
is as it is.
yeah, we'll take all of the x squares, y squares, and z squares, and like we'll take the 2 common because
Yes.
it becomes 2x square, 2y square, 2z square. So we'll take the 2 as common, and then we have minus 2xy, minus 2yz, and minus 2zx. we'll take that differently as well.
Yes. So we can just take the 2 common from
As
every
common. Yeah.
from every term. We can just take the 2 as common from every term. So we are taking the 2 as common. Okay. Now
Yeah,
what do
so
we
it
have
becomes
remaining
1.
inside the bracket?
X square plus y square plus z square minus xy minus yz and minus zx. So
Avni,
this
are you
is equals to
understanding?
the left hand side and hence proved.
Okay. So this is equal to the LHS. LHS of what? This one. Let's call it 4 or whatever. Okay. Equal to the LHS of 4. So what have we proved? We have proved that this B is equal to C. We have proved that B is equal to C. So if A is
Yeah.
equal to B and B is equal to C, that means A is equal to C, right?
C, yeah.
So let's write from, again, this will be equation 1. Okay. Since let's do one more thing. So let's multiply the 4th equation, this one, which we have just shown, with x plus y plus z. This way it will be more clear for you guys. We are multiplying it with x plus y plus z on both sides of the equation. Obviously, not on one side, because when you're multiplying something with an equation, when you're multiplying an equation with something, then it obviously has to be on both sides so that it will balance the equation. Otherwise, it won't remain an equation anymore, right? Anyway, so we are multiplying it with x plus y plus z. Why? Because we need it in the final equation. That's why. So yeah, what does the LHS of equation 4 become after multiplying it with x plus y plus z? Yeah, what happened? Any doubts?
No.
No, ma'am.
Then someone tell me.
4x plus
4
4.
x plus
No,
4y.
no, no. Not 4. Where is 4 coming from? This is equation 4.
Oh.
Okay. This one is equation 4.
Hmm. We get
This-
the equation x cube plus y cube plus z cube minus
Right now,
3xyz.
right now, what do we get when we multiply this, the LHS, with x plus y plus z, and the RHS of equation 4 with x plus y plus z? Then what do we get? Right now, this is what we are doing.
We get
X plus
A,
y plus z
which is, yeah,
multiplied with the
Four.
LHS of the left, LHS of the equation, right? Which is this one. Is it fine till here? What are we doing? You guys are clear?
yes, ma'am.
Avni, is it clear for you?
Yes, ma'am, clear.
So we have multiplied that, the 4th equation, with the bracket x plus y plus z. So this becomes equal to, again, we are multiplying the RHS also with x plus y plus z. So then that becomes now look at this. We have shown that B is equal to C. And this is exactly what we needed, right? We had, this thing is what we had in equation number 1, what we knew, and this thing is what we had to show. So therefore, from equation 1, x cube plus y cube plus z cube minus 3xyz, this was equal to this was equal to this thing. Yeah, look at equation number 1.
Yeah.
The yellow part was equal to this thing. And we have shown that it is instead equal to this portion. And this half we are going to bring in front. So any doubts after this? Acha, is it clear for everyone now? Or are you still finding it difficult? Yes, Abdul
No, ma'am.
Jabbar? Yeah, Abdul Jabbar? Clear? Okay. Preshita?
Yes, ma'am.
Clear? Okay. Fine. Shall we move forward or you guys have to write it now?
Ma'am, 1 minute, let me write it. 1 minute.
In 9th grade, you have a lot of these dry things, theorems and prove this and prove that. It gets a little boring sometimes, but in 10th grade, it will be better. But actually, the important thing about 9th grade is that everything you study in 9th grade is going to form a basis for what you study in the higher grades, especially in 10th grade. So it's kind of like do the hard stuff now, do the difficult things now, and then in 10th grade, it becomes easier. So this is basically your foundation stage. Done? Shall we move ahead?
Yes, ma'am.
Okay. So, acha. Now based on, not based on this, but it's a different question actually. It's a very easy one. This one you will find comparatively easier as compared to the previous one. Okay. So this one says that if x plus y plus z equals 0, then show that x cube plus y cube plus z cube is equal to 3xyz. See, right now, since we are doing this chapter, it is comparatively easier for you because you know that, okay, we have just now done this particular identity. So you know that, okay, I have to apply this identity. But in the exam, it's not going to tell you, oh, that is the identity you have to apply. They're not going to tell you. So you just have to remember it to such an extent that you, when a question is being asked, even without the identity being shown in the question, you can just apply it. So the moment you see x cube plus y cube plus z cube, and you see this thing, 3xyz, what comes to your mind? This identity, the equation number 1 that we have written over here. Yeah? They are saying in the question that x plus y plus z is equal to 0. That means this portion is equal to 0. This entire bracket is 0. Yes or no?
Yes.
Now, since the right hand side may one bracket is 0, so the entire RHS becomes 0, right? 0 multiplied by whatever stuff is going to be 0, right? So the RHS becomes 0. So let's write the identity first. Okay. Solution. We know that. Yes, who will tell me what the identity was? Abdul Jabbar? What was our identity which we've been doing? Avni?
Yes, ma'am.
What was the identity?
X x x cube plus y cube is equal to z cube minus 3xyz.
No. Our identity was x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z multiplied by some huge bracket. Remember?
Yes, ma'am.
Yeah. This. Write it down till here first. Now they are saying that your x plus y plus z is equal to 0. That means this portion is equal to 0. So that implies x cube plus y cube plus z cube minus 3xyz is equal to 0 into some bracket. Now 0 into anything is 0 itself. So we're just going to write the RHS as 0. Now you take the 3xyz to the right hand side. This becomes x cube plus y cube plus z cube is equal to 3xyz. And that is what we had to show. See, to show that this thing. Now this is something you need to remember. This results that if x plus y plus holds true, this becomes this thing holds true. I think my screen is
Ma'am, your voice is breaking.
yeah, just a minute. Is my voice better now?
Yes, ma'am.
Okay. So what I was saying was, you need to remember this fact, okay, that if x plus y plus z becomes 0, then x cube plus y cube plus z cube, it becomes equal to 3xyz. So they are saying in the next question, they are let's take some examples. For example, you have you have three numbers x, y, and z. Okay, let's say your x is 2, your y is 8, and your z is 10. Okay, minus 10. Fine. These are your three numbers, x and y and z. Now, if someone asks you to find 2 cube plus 8 cube plus minus 10 cube, in I know it's pretty easy to just calculate their cubes, but what if you have bigger numbers, right? So we can verify that this is going to be equal to 3 times 2 into 8 into minus 10. 3x, y, z. How and why? Because x plus y plus z is equal to 0. Can you see? 2 plus 8 is 10, minus 10 is 0. So since x plus y plus z is 0, that is why we can apply this thing. X cube plus y cube plus z cube is equal to 3xyz. Okay, so you see what is on the LHS, you have 2 cube is 8, 8 cube is 64, and then minus 10 cube is going to be minus 1000. So this becomes 72 minus 1000. And that is how much? 72 minus 1000, calculate it. This is equal to negative 928. Okay. And now you see this thing, your RHS. This is also going to be equal to negative 928. Oh, sorry. Just a minute. This is not 64. I made a mistake. 64 into 8 is how much? 512. So this is going to be 520 minus 1000. That is how much? 480? No. Minus 480. So see this. This is 3 2s are 6, 8s are 48 into negative 10, which is minus 480. So x cube plus y cube plus z cube, it is coming out to be equal to 3xyz. The reason is because x plus y plus z was 0. If it's not 0, then this thing is not going to be true. The yellow part is not going to be true. So let's do another question based on this. This is going to be the last question for today, okay? But just do it, all of you. Minus 12 cube plus 7 cube plus 5 cube. Can you guess what will this be equal to?
Minus 144 plus 2.
No. Since x plus y plus z is 0,
Okay.
see, minus 12 plus 7 plus 5 is what? 0, right? Since x plus y plus z is 0, therefore x cube, this is x cube, plus y cube plus z cube is going to be equal to 3 times what? X, y, z. So now what is x, y, z? 3 into minus 12 into 7 into 5. Find this out. What is this equal to? What is this equal to? Who will tell me?
1 minute.
See, 12 fives are 60, right? So minus 60 multiplied by 3 sevens are 21.
Ma'am, 221.
Mm,
Uh,
no.
210, sorry, minus 210.
How is going to be minus 210? There's 60. Bache, this is not 2. This is 12.
Oh,
Ma'am, 300.
No.
1260.
Very good. Negative 1260. This is going to be the answer. Okay, just one last question for homework. The same thing you are supposed to apply. 28 cube plus minus 15 cube plus minus 13 cube. Okay. All right, students, any doubts from today's class?
No, ma'am, no doubts.